So, hey guys, so this is Chanel, and in this video, I'm gonna do the hardware demonstration of Lab 8 of my Embedded System Design class entitled FIR Digital Filter. So, this is how I connected the hardware in order to measure the chip select to do the MATLAB simulation. Yep. This is how I connected the EGC. And this is where from I already run the code. This is the initial code with my value from the least significant bit of my TID. So when I run it, let me just auto set it. Yeah, when I auto set it, and then if I stop it, it's at 225. And it's at 220, so it's between that range. 220 again, so 220 kilohertz. So I'm gonna use that value for my MATLAB simulation. So now I'm gonna demonstrate. I'm gonna show how my signal responds according to the frequency response and the input frequency. So this is how I connected my hardware. The yellow wire on the LGC and the blue, orange and blue wire on the GAC. So I already run the code. This is the code. I already run it, and let's go to the waveform. This is the wave generator. So right now I input at 200 hertz. So if I run it, my original signal is the blue channel. So as you can see, there's no attenuation yet. So if I change, let me change this one to 5 kHz, and we're gonna start to see the change. Let me to set it. So now we can see the change. The original signal on the yellow signal has some attenuation with a phases, and as you can see, the input value is about 176, something like that, and the output is 121. Yeah, so if I change it, we're gonna see more attenuation. So the more we increase the frequency, the more we see attenuation until we don't see any more signal. So let me increase again. 10 kHz. So let's go now to 20 kilohertz. See, we are still getting we still have a correct amplitude, but with more attenuation, and we can see the phase pretty good. Yeah, so if I change frequency to let's say 50. Okay, so now we can see we are not getting the amplitude correctly anymore. So we are not getting mesh point anymore, and if we stop it and we see the input and output signal, you can see that it's like way too much that for this channel 1 is 13, for the channel 2 is 161, so it's too much. So we're not getting amplitude correct anymore at this point. And if I go to 100 is actually my sampling frequency over to the Nyquist frequency, because my sample frequency was 220 something, and then so if I go to 100, we're not even gonna see. So let's see. Don't even see something anymore. See, you don't really see anything anymore, because we are at a like, yeah, you don't see anything. You start to see aliasing, and the signal start to overlap at 100 hertz. This is the limit. So if I go to 200 hertz, is the input frequency will, which the signal will fall apart, because it has reached the limit. So as you can see, the signal fall apart. Okay.